Hello, this video is about orbitals. You're going to learn about the shapes of orbitals, the numbers that we use to label them, which are called quantum numbers, and we can learn about how the electrons will be arranged once we know about orbitals. There's at least three basic types. There's actually a fourth one. Orbitals come in a shape that's spherical. It's called an s orbital. But you got to think of it as a balloon rather than like a solid object like a bowling ball or a marble. That will hold 2 electrons. There's a p orbital, looks like a dumbbell, and that also holds 2 electrons. And a d orbital, which holds 2 electrons, has this clover leaf shape. And what's important is that not only do they hold 2 electrons, but there's places where electrons don't exist for that wave function for that orbital there. So that's called a node. And in this case, it's like a plane, a piece of paper that you would slide between those 2 bubbles there in the p orbital, and between the 2 sets of bubbles there for the d orbital. It has two nodes. Well, these are the shapes then and orientations of a bunch of different orbitals. And so you can see with the 1s orbital down here that it's a small spherical shape. As we go up in energy level, we can create a new s orbital, but then p orbitals are available. There's 3 of them. When we get to the 3rd energy level, there's another s orbital that's bigger, and then there's p orbitals that are also larger than the energy level below, because that means the electron is farther away from the nucleus. But then d orbitals show up in this 3rd energy level. And in the 4th energy level, you get s, p's, d's, and a new type of f. Now you can see the numbers here. There's 1 kind of an s, 3 types of p's, and 5 d's, and there'll be 7 f's, and if there was g's, there'd be 9 of them, and if there was h's, they would be 11 of them. And we got to think of these orbitals all stacked up on top of each other, kind of like Russian dolls, how they all fit inside of each other. The way to understand orbitals in quantum numbers is that when we're trying to address somebody and get a letter to them, we use 4 different labels to get to them: the state, the zip code, and the street address, and finally their name. We'll get a letter to the right person. We're going to do the same thing. We're going to have 4 numbers to find the location of each electron in an atom. The first one is the principal energy level, n, and it has a value of 1, 2, 3. Depends on the energy level that we find that orbital. L is the quantum angular number, and it's a number assigned to the shape, 0, 1, 2. If you're dealing with s orbitals, that's L is 0. P orbitals are L is 1. D orbitals, L is 2, and F, L is 3. Those are our main ones. Then there's quantum number, M sub L, and that has to do with the orientation. Is it along the x-axis, the y, the z? How is it different from the other ones? And then lastly, to find the electron, within each orbital you can have 2 types of electrons. They call it spin up or spin down, plus 1/2 or minus 1/2. Why? Because those are the numbers that come out of the quantum chemistry calculations. Each electron is going to have a unique set of 4 quantum numbers. Now, for the orbitals, let's think of them as like a little hotel. On the first floor, you can only have an s orbital. So that means energy level 1 can only have an L equals 0 s orbital. Second floor has more room, and you can have p orbitals. Third floor, 3rd energy level, can have s, p's, and d's, and then the 4th one you can have s, p, d, and f. So each energy level can have an s orbital, or I like to say the p wing, or s wing, and then the p wing. And then there's a sub-level of d's that you can have, and then lastly you can have f's. Now each one of these rooms, or orbitals, are going to be given numbers. As you can see here, anytime you're dealing with an s orbital in the s wing, it's just going to be called a label 0. And then there's going to be the label -1, 0, and 1 for the 3 p orbitals. And then for the d's, you go from -2 to 2, and f, as you can see, -3 to +3. So we got to remember then the floors have a number, and those are the n's. N stands for the energy level. It's not nodes, it's energy level. If we're talking about s orbitals, those are going to be L equals 0s. If we're talking about p orbitals, then L is 1. Talking about d orbitals, L is 2, F, L is 3. So there's letters and numbers, as you can see, for a lot of these things that we're talking about. So we got to keep that in order here. Okay, so hopefully you can see that anytime we're dealing with an S, that's always going to be L is going to be 0 for those. I'm sorry, actually these numbers here are what we call the M sub L numbers. So if we're talking about this orbital, we'd have n equals 1. It would be an L equals 0 because it's in the S wing, and then the M sub L is 0. There's only one option for it. Talking about p orbitals, the p orbitals here, to get to this room, I need to know that it's n equals 2, L, it's in the p wing, is 1, and there is a minus 1 to characterize that. So each hotel room has 3 numbers to get to that room. Okay, but if there's 2 electrons that can be in those rooms, how do we differentiate between those? Okay, that was the M sub L number that you can see goes with those labels for each room. So once again, those are the principal energy level numbers. There's the angular quantum number with L's, L equals 0, L equals 1, L equals 2. And then the M sub L's then are listed here, showing that all again. That helps you to figure out what suborbital you're talking about. But then you can have plus a half or minus a half in each one to designate the 2 electrons that fit in there. Anytime you see 3 quantum numbers, the N, the L, and the M sub L, you'll know what orbital you're talking about. Then you need the 4th one to tell which electron you're talking about. Spin up or spin down. It's important to know the px, py, and pz, but you should also know the d orbitals. d, y, z, you can see the lobes are actually in between the y and z. The dxz, the lobes are between the x and the z planes. And the dxy, the orbitals actually fall in, you can see here, in the xy plane, but in between the axes there. dx squared y squared are actually right along the axes for x and y, so it's very similar, but just spun a little bit, maybe 45 degrees from the dxy. dz squared is very strange, but it's a d orbital you need to know. It's a dumbbell with a donut around it. Pretty exciting. All right, orbital designations. One way you write these things is, let's get a pen going, is if we want to find, we want to see something, let's say someone wrote 2p x. Well, this right here is the n equals 2 energy level. This is referring to L equals 1 for p orbitals, and this is an M sub L number, and we'll go ahead and just call that minus 1. So we'll use that designation for the orbital to see if there's an electron in there. And then later on we'll write, if we want to know if there's electrons in there, we'll put like a superscript in there for 1 electron that's in it, or maybe change that for a 2. So we want to get to that, but we need to know how the numbers are described. Here's like a question you might get asked. For the principal quantum level n equals 4, how many allowed subshells? Okay, so now we're dealing with the 4th energy level, so you can have the S subshell, you can have the P subshell, and the D, and the L. So that looks like 4 different types of subshells that are allowed. That doesn't mean that all of them, you need to use them all, it's just that's how many are available or allowed there. Okay, we were right, excellent. Okay, so, and it's important to remember that this is 0, this is a 1, L equals 1, L equals 2, L equals 3. Okay, SPD, oop man, that's supposed to be an F. All right, let's go on. For L equals 3, okay, how many orbitals are described? Well, L equals 3 is dealing with, let's see, 0, 1, 2, 3. This is the F orbitals. Okay, there are 7 F orbitals. So we're dealing with 7 F orbitals then. Okay. Just a little note about electron spin in case you had a question about that. It can be plus half or minus half, and that's the 4th quantum number. And sometimes we write it, you'll see sometimes that instead of writing plus 1/2, we'll just do an up arrow or down arrow there. This is a good OWL question you may come across, just to kind of get an idea of how you see these things. So your S orbitals there are spherical, and they're trying to show that here. And as you get to the upper energy levels, not only will you see a slightly bigger electron dot pattern, but you're going to see little rings, it's called a node, where you don't see any electron density. So there is one node for the 2s orbital. The 3s orbital has 2 nodes in there, and so those are maybe areas you can think of where the smaller s orbitals are fitting. Okay? We actually have no letter designation for spherical nodes. We just will ask how many spherical nodes or how many nodes are there. Spherical just means it's a round node. Some things have angular nodes, which are then more like a line through there. This one has a spherical and a line through it. This one has 2 lines through it, 2 planes, where electrons are not found. So that's what we're referring to with nodes. All right, if you have an n value of 3, what are your different quantum numbers that you can have for L? Well, if you're in a third energy level, you can have s orbitals, p orbitals, or d orbitals. So they can go from 0 to 2. Total number of orbitals possible at the n equals 3. Total number of orbitals, well, this will have, let's see, there's 1 orbital there, and there's 3 orbitals there, and 5 for that. So 5 plus 3 plus 1, that looks like 9 orbitals. And let's see for right there. Oh, we're doing good so far. All right, so we're getting this figured out here. Let's do this last one here. If the value is L equals 3, oh man, L equals 3, that means we're dealing with F orbitals. Okay, quantum number of n sub L can have values from -3, from L to L. Because if you count from -3, -2, -1, there's a 0 label, a 1, and a 2, and a 3, then that's an orbital. -3 is an orbital, -2 is an orbital, -1 is, and so all of those numbers are orbitals. And how many are all together there? You're going to find that there's 7 of them. Let's see if I got my answers right. Oh yeah, doing great. Okay, so now you're just going to get examples, and you got to figure out what they're talking about. Just remember to read the directions. It says give only one value for each. Okay, we're dealing with the 2s orbital, so there's n is the principal energy level, L. Well, we're talking about a s orbital, and there's only one value for m sub L, that's 0 for that. And then I can be the plus half or the minus half. There's a total of 1 value for the m sub L, because there's only 1 value for that when you're dealing with L equals 0. So you got to keep practicing this, and just read the directions, and you'll be all right. Students do get this wrong just because they're having a hard time understanding the directions. Okay, so I have some values here that can go in, and so you can think about some of those. All right, I think we'll stop it here. You've got some good directions so far, and hopefully this will help you understand orbitals.